Hello, Algebra 2. Hope you guys are having a great day. Today, we're going to be doing something called completing the square. And this does one of two things. One, it can turn a quadratic that is in standard form, it can turn it into vertex form, or it can help you solve an equation. Okay, so it doesn't really matter. I mean, it just depends on what the question's asking you to do. It's just a strategy, a tool in your toolbox to be able to do those two things. Okay? So, that's what we're going to be doing. Solving equations using completing the square and writing quadratic equations in vertex form using completing the square. Alright, so the first thing you need to know is this thing called the square root property. Okay? And basically, all that says is that if I have an equation that on either side it has perfect squares. So something like x squared equals a, or let's try a number, x squared equals 16. The square root property, the square root property says that you can take the square root of both sides, okay, as long as you do one thing, the same thing to both sides, right? You can take the square root of both sides, doop, boop, and here's the thing, right? Something squared equals something positive, right? If I have 4 squared, I get 16. But if I have negative 4 squared, I can also get 16. So, because of that, you actually get two answers when you take the square root of both sides. Now, if I just start with a problem like x equals the square root of 16, if I start with this, you don't get a plus or minus because you're not actually explicitly taking the square root of both sides. I'm giving you that x equals the positive square root of 16. Okay, so that is not a case where you get a plus or minus. But if you start with a something squared and you take the square root of that, then you end up with a positive and negative answer. So x ends up being positive or negative square root of 16, which is 4. Okay, and the square root property just basically allows you to do that. So I'll write that down for you. Alright, so this is really useful in examples like the following. Now, if you'd like to try them first before you see what the solution is, then go right ahead, pause it now, and then check your answers. Otherwise, you can follow along with me. Also, if you do it on your own and you get the wrong answers, then go back and watch the video, FYI, in case you didn't make that decision. I'm making it for you. Okay, alright, example 1. 3x squared minus 4 equals 71. So, I'm going to blow this up a little bit. Now, if you have a problem like this, right, in this case, I can add 4 to both sides. I get 3x squared equals 75. Divide both sides by 3, right? The idea is you want to isolate the variable, right? So you got to pretend that x squared is just x by itself, right? And solve it like you would normally solve it in this case. And then you get x squared equals 25. Then you can take the square root of both sides, right? Because the square and the square root cancel each other out. You get x equals, because you took the square root, you get a positive or negative square root of 25, which is just 5. So you get two solutions, positive 5 and negative 5. Okay? Alright, next problem. X squared minus 10x plus 25 equals 27. Now this one is a little bit different because if you take a look, this side by itself factors really nicely because x minus 5 times x minus 5 ends up factoring, right? This is what it is factored. So because negative 5 times negative 5 is positive 25, and negative 5 plus negative 5 equals negative 10. So we're good there. That equals 27. And then we can write that as something squared, x minus 5 squared. Hold on a second, I have to go check on the dog because I think he's peeing in the other room. Okay, no p. We're good. All right, anyways. So now you've got something squared equals 27. So we take the square root of both sides, take the square root of both sides, and my square and my square root cancel. I get x minus 5 equals the positive and negative square root of 27. Okay, then you add 5 to both sides. I get x equals 5 plus square root of 27 is one answer, and 5 minus square root of 27 is the other answer. Okay, so you get two solutions. All right, last problem. 4x squared minus 20 equals 5. Now, if you notice, if you add 20 to both sides, you end up with 4x squared equals 25. Then, I have a couple options at this point. I prefer to divide by 4 first, because then I don't get confused about where the plus and minus goes. So I go x squared equals 25 over 4. So now we just have something squared equals a number. We can take the square root of that, both sides. Same thing that we were doing before. When you take the square root of both sides, you get plus or minus. You get x equals plus or minus square root of 25 over 4, which is plus or minus 5 over 2. So there are two solutions, right? Your two solutions are x can equal 5 over 2 or negative 5 over 2. Okay? Cool. Alright, next. Officially completing the square. Alright, so here's the thing. With completing the square, there's a bunch of steps that you need to do. The first, so I have all these steps, right? 1, 2, 3, 4. And eventually, once you do it enough, it will be fine. And so I could read the steps to you, but I think it'll make sense if I just show them to you, okay? But you have to start with it in standard form, okay? If it's not in standard form, then this doesn't make any sense, right? So b is the, right, if it's ax squared plus bx plus c, this is your b, right? So it's the second term coefficient. Anyways, all right, so you divide b by 2, square it, add it to the original problem, and subtract it, and then write it as a complete square. Okay, so wait, what? That doesn't really make any sense. Like I said, it'll make more sense if you just see it. Okay. The other thing is, if a is a constant other than 1, you have to pull that out before you complete the square, or divide it out. Okay. All right, so let's try a few examples. Use completing the square to find the roots of the following equations. So let's do the first one together, and then I'll let you go off on your own and try them. Okay. First one, x squared equals 27 minus 6x. So first thing you want to do is like get everything to one side. So let's see here. Let's keep the x squared positive. So I'm going to add 6x and subtract 27 to one side. Okay, so I have all that equals 0. And then the first step, once I have it in standard form, right, which is ax squared plus bx plus c, I divide b by 2. So 6 is b, so I divide that by 2. Okay, so that's my first step. And I like to do this little boxy thing. It makes sense to me. 6 divide by 2, and I end up with 3. I take that number and square it. 3 squared, which is 9. That's the number that makes this thing a perfect square. So you add it in, but the problem is, if you add it in, you either have to add it to both sides to keep it so that it's equal. So add 9 to the left and add 9 to the right. Or if you want to keep the left at 0, you have to add 9 to the left and subtract it out as well. Okay, so what does that actually look like? Right, so I've got an x squared plus 6x plus 9 minus 27. I'm going to leave it like that and then subtract 9 as well, right? Because really effectively all I've done is added 0, which didn't change anything. I added 9 and I subtracted 9. So I didn't actually change the equation at all. So this part, the x squared plus 6x plus 9, that is a perfect square. Because if you try to factor that, x plus 3 times x plus 3 satisfies, right? It factors. That's how that factors. And then I have minus 27 minus 9. So minus 36 equals 0. So then I can continue. I'll write it as a perfect square, x plus 3 squared, and minus 36 equals 0. I'm going to add 36 to both sides, and I get x plus 3 squared equals 36. Take the square root of both sides, and then I have x plus 3 equals, remember I took the square root of both sides, so it's plus or minus square root of 36, which is 6. So I end up with, I want to subtract 3 from both sides. So I get x equals negative 3 plus or minus 6. Well, that's not really a nice number when I could make it a nice number, so I'm going to do that. So x is negative 3 plus 6 and negative 3 minus 6. So x equals positive 3 and negative 9. And those are my two solutions for the first problem. Alright, so number 2 is an example of this highlighted case here at the bottom, because you have this, I'm going to bring the 12 to the other side just so that we're consistent, 2x squared plus 8x minus 12 equals 0. Okay. The problem is we have this 2 in front of the x squared, and it's less easy to deal with, and you can't complete the square unless that's not a 2. So we want to pull that out, right? So I could take that 2 out, and then I have x squared plus 4x minus 6 equals 0. And in this case, right, since I have a 0 on the other side, I can divide both sides by 2. And my 2's cancel there. 0 divided by 2 is just 0. So I end up with x squared plus 4x minus 6 equals 0. Then I can complete the square on that. So then I take b, which is 4, divided by 2. So 4 divided by 2 is 2. Then I take that and square it. 2 squared is 4. And that's the number I add in and subtract out. Okay, so I have x squared plus 4x plus 4 minus 6 minus 4. Because remember, I have to add it and subtract it, equals 0. This thing is a perfect square. X plus 2 times x plus 2 minus 10 equals 0. And then I can add 10 to the other side, take the square root of both sides, so I get x squared, x plus 2 squared equals 10. Take the square root of both sides, and I get x plus 2 equals plus or minus the square root of 10, right? Which is x equals, I subtract 2 to the other side, x is negative 2 plus or minus the square root of 10. So your two solutions are, you can leave it like this, but just so that you understand the difference, that there are two solutions. Negative 2 plus the square root of 10 is an answer, and negative 2 minus the square root of 10 is an answer. So either of those would be fine answers. Go ahead, check your answer to 3, and then we're going to move on to the last couple examples. Alright, the next examples are putting quadratics into vertex form. And the main difference is that there's a f of x on one side instead of a 0. Okay? So you can't actually solve for x, you can just like rearrange it. So we do the same thing here to complete the square. Since there's a 1 in front of the x squared, we don't have to do anything there. Take the 10, divide by 2, 5 squared is 25. That's what we add in and subtract out. So anyways, the x squared plus 10x plus 25, that's our perfect square. because x plus 5 times x plus 5 equals that. So I've got x plus 5 squared minus 19 minus 25, which you can simplify. So far that's what f of x equals. And if you look at it, right, x plus 5 squared minus 44, this is equal to what we started with, except now we have the function in x minus h squared plus k form, right, where h is negative 5, k is negative 44, so the vertex of this parabola is negative 5, negative 44. Just an FYI. But if the question was just to like write it in vertex form, this would be our answer, because that is vertex form. But you can easily get the vertex from vertex form. That's all. And since we're out of time, I'm just going to go through the solutions to the next two. So try them, make sure that you understand how to do this. The only thing that's different for number 2 is that you have that a value in front of x squared. So make sure you pull that out first, right? And it's probably the easiest and makes the most sense if you divide both sides by 2, and then you just leave g of x as g of x divided by 2, and then later you can multiply it back over. But then you have x squared minus 4x plus 5 over 2, and then you can complete the square on this side. So when you get to this point where you have everything in vertex form, but you have g over 2, right, you have to multiply both sides entirely by 2. So g of x over 2 times 2 is just g of x, and that's what we want. But we have to multiply it, right, distribute the 2 onto both terms. So you have 2 times x plus 2 squared minus 2 times 3 over 2, which is just 3. So then the information you get is that there's a vertical stretch by 2. It moved left 2 and down 3. So your vertex is negative 2, negative 3, and it was vertically stretched by 2. All right, and then try the last problem on your own. And the solution to the last one is h of x equals x plus 3 squared plus 10. So the vertex is negative 3, negative 10. Or sorry, negative 3, positive 10. It's getting late. All right, there you go. Good luck. See ya in class.